Diamond planets. Imagine stepping onto a planet where the ground beneath you sparkles like an endless field of diamonds. It might sound like science fiction, but some exoplanets, like 55 Cancri E, are thought to be composed largely of carbon under extreme pressure. On Earth, diamonds form slowly deep underground, but on these planets, conditions are so intense that entire planetary layers could crystallize into diamond. This isn't just a shiny surface. The planet's interior might contain diamond mountains, crusts, and possibly rivers of molten lava glowing over diamond plains. Scientists call these diamond worlds, and they make us rethink what planets can look like. Unlike any planet in our solar system, these alien jewels combine beauty with deadly extremes of heat, pressure, and volcanic activity. Rogue planets. Not every planet has a star to orbit. Some drift alone through the galaxy, untethered, invisible in the dark. These are rogue planets, lonely wanderers, millions of them possibly roaming the Milky Way. Without a sun, they are mostly frozen, but if they have thick atmospheres or internal heat from radioactive decay, they could still maintain liquid oceans or even underground ecosystems. Imagine a planet traveling through complete darkness, with no sunrise or sunset, silently moving through the void. Rogue planets are like cosmic ghosts, hard to detect, and even harder to understand. But their very existence tells us the universe is stranger than we often imagine. Neutron stars and pulsars. When a massive star ends its life in a supernova, its core can collapse into a neutron star. These stars are incredibly dense. So dense that a single teaspoon of their material would weigh more than 1 billion tons on Earth. Some neutron stars rotate incredibly fast, and their powerful magnetic fields create pulsars. These pulsars act like cosmic lighthouses, sending beams of radiation that sweep across space at hundreds of times per second. If you were nearby, the flashes of light would be blinding, yet from Earth we detect them as precise pulses. The energy in a neutron star is astonishing, more than our sun emits in a lifetime, and yet it's contained in a sphere barely 20 kilometers wide. Pulsars challenge our understanding of physics, offering a glimpse into extreme matter and energy beyond everyday experience. The Boomerang Nebula. The Boomerang Nebula is the coldest known place in the universe, with temperatures dropping to nearly absolute zero, minus 272 degrees Celsius. Colder than the cosmic background radiation itself. This frigid nebula is shaped like a bow tie, with gas expanding outward at hundreds of thousands of kilometers per hour. It's a stunning reminder that space isn't uniformly hot or cold. There are extremes that defy logic. The Boomerang Nebula formed from a dying star shedding its outer layers, and as the gas expands, it cools rapidly, creating this frozen spectacle. To imagine a place colder than anything on Earth, where molecules move almost imperceptibly, is to grasp the sheer variety and strangeness of our cosmos. Spaghettification. Near a black hole, gravity isn't just strong, it's extreme beyond comprehension. Any object venturing too close experiences tidal forces that stretch it head to toe into a thin, elongated shape, a phenomenon called spaghettification. If a person fell in, they would be stretched into a narrow strip, pulled apart atom by atom before reaching the event horizon. This isn't a metaphor. It's a real prediction of Einstein's general relativity. Black holes don't just warp space. They literally tear objects apart. The closer you get, the more violent the stretching, and nothing can escape once past the point of no return. Spaghettification is one of the most dramatic examples of how the universe can bend reality itself. Interstellar visitors. Occasionally, our solar system receives unexpected visitors from other star systems. The first confirmed interstellar object, Oumuamua, passed through in 2017 at incredible speed, unlike anything bound to our sun. Its elongated, cigar-like shape and unusual trajectory baffled astronomers, sparking speculation about whether it was a fragment of a distant planet, a comet, or even something artificial. Interstellar visitors remind us that the solar system is not isolated. It's part of a cosmic highway, with objects traveling light years to briefly pass by us. These objects provide rare glimpses into the material and history of other star systems, giving clues about worlds we may never visit. Magnetars are some of the most powerful and mysterious objects in the universe. They are neutron stars with magnetic fields trillions of times stronger than Earth's. Their magnetic power is so intense it can distort atoms and even wipe out electronics from thousands of kilometers away. The energy released in a single flare from a magnetar can outshine the sun for a short period, sending deadly bursts of radiation across space. These objects are rare but terrifyingly powerful, demonstrating that the universe holds forces far beyond human comprehension. Magnetars are like the ultimate cosmic battery, storing energy that could obliterate anything nearby in an instant. Cosmic voids. The universe isn't a uniform sea of stars and galaxies. Some regions, called cosmic voids, are massive empty spaces, hundreds of millions of light years across, with very few galaxies inside. They are like deserts in the cosmic landscape, surrounded by clusters of galaxies, filaments, and dark matter. These voids make up a significant portion of the universe's volume, and yet they remain almost completely empty. Studying them helps astronomers understand the evolution of the universe, the distribution of matter, and the invisible forces shaping everything. Cosmic voids are quiet, vast, and haunting, a reminder that even in a universe teeming with stars, emptiness can dominate,